Okay, so this is the time. The talk is going to be in English, just for your intention. So my name is Amélie. Thank you all for coming to this talk just before the lunch. I'm a software engineer in test for the streaming team in Ubisoft Bordeaux. So for this talk, I will actually present part of my work that I've been doing during my first year at Ubisoft. So let's dive in and try to test things that don't want to be tested. So first, I will start with a bit of technical context. So when we talk about streaming video games, we actually need to understand first three fundamental notions. So the first thing is that we are doing real-time stuff. Because we are doing streaming of games, the player will actually want to interact with the game, so we need to answer to his action as soon as possible and with the right information. Then we want our stream to be stable, because the players are living in all around the globe. So we want to have a stream that is consistent and stable on varying network conditions. And then to finish, we need to have the stream that is pristine, because the game is a work of art that is being created by our teams at Ubisoft, and we want the stream implementation to not play with, to not disturb the experience. So what is the difference with classic video streaming solution, like for example Netflix? Well, video games are interactive, so like I said, the players will send inputs, and then we will need to answer with the right information as soon as possible. Then, for this reason, we cannot allow any buffering or caching of data because it will add too much latency, and we can't afford that for streaming video games. And then we will need to mitigate the effect of packet loss on our stream, because it will happen. And last but not least, we are also, for our case, we are working with peer-to-peer connections, so we don't have any content delivery network that are optimized for streaming the game. So, for example, we have a product that you can actually test in our Ubisoft stand. It's called SharePlay, and so it works by a player inviting any of their friends to play a game, and what it does is actually stream the screen of the player one to one of their friends. So also, why testing streaming technologies in general is pretty complicated, is because we can stream to any kind of hardware devices. So it can be TV, mobile, tablet, consoles. And also, the players will be able to interact with the game with different types of inputs. So, for example, with mouse and keyboard, with touch, or even with gamepads. And also, all these hardwares have GPU and CPU characteristics that are different between them. They also have software implementations that are different. So, all these devices come with different types of OS, version of generation, and even driver implementation. And then, last but not least, because it will be too easy like that, we also have different types of networks that you can connect your devices to. So you can connect your devices through Ethernet, through Wi-Fi, through 4G, and you can even change on the go. And through testing, what's the most important thing that we want to test, to be able to analyze, is the playability. So the playability is the perception of the gameplay quality. And as you can see, there are a few factors that can really impact that playability. So it can be impacted from the video side or even from the network side. And also it can be divided into two subcategories. So we have the objective factors that are quantifiable, and they are usually set, like the resolution or the bandwidth. And then we also have subjective factors that, like it says, is subjective. So every player can have a different perception of the game, of the quality of the game. And it can vary a lot between players. So casual gamer and very experienced gamer won't have the same, won't be exigent in the same way. So I won't go too deep and define everything here. We will focus for the rest of the presentation on network. So we have three key metrics when we talk about network. So first we have the bandwidth. The bandwidth is the maximum capacity of data that can be transmitted over a network connection. Then we have the latency, which is the amount of time taken per packet to travel between two devices. And then we have the packet loss. The packet loss will occur when a packet or more fails to arrive to its destination. So all of these metrics are defined by which type of network you are using, by which internet service provider you are subscribed to, where you live, or even how many people are using the same network as you. What you also need to understand is that even if all of these metrics are pretty bad, but constant, we can still have a stream which is in bad quality, but we still have something. But if we have any variation of these metrics, for example, the latency will vary in a sudden way. It's called the jitter, and it will really impact and deteriorate the stream because we can't really anticipate and correct what's happening. And if we continue to focus on latency, latency is not only introduced by the network, it's also introduced by the hardware. So for example, your controller can take around 4 milliseconds to send an input. And then your screen can also take between 4 to 16 millimeters to refresh a frame. And for TV, it's even more. Like, it can be like 30 milliseconds or even more. Then your encoder can also add latency. So to encode or decode a frame, you can take up to 5 to 10 milliseconds. And this is really important because, like I said, we want to stream something in real time, and we want it to be interactive. And actually, humans can process visual stimuli in about 13 milliseconds. And when we see that the latency, when the latency starts to go above the 100 milliseconds, we can start to notice it, and we start to anticipate our actions. So that's why it's really important for us to focus on latency and try to minimize it as much as possible. So our goal, as Ubisoft, is obviously to create the best experience for our players. But my goal in the streaming team is to test the products and try to make sure that we deliver the best experience. So we've created a solution that is pretty simple for problems that you've seen is pretty complex. So first, we will define the test case. We have a host that is launching a very basic application of the streaming. And then the guest connects to it, so you see it has the same image. And we want to stream that on controlled network conditions. So we want to do that because we want to understand how the streaming works. We really want to understand how our technology is impacted by the network. And also we want to have a test pipeline that is able to validate any change that we do on the streaming technology. So like that, it might look a little bit simple, but actually we had some difficulties because first we needed to work on Windows machines. It's enough to be complicated, but the problem with Windows is that we don't have as many automation tools as for other types of OS, and also we needed real user sessions and real graphical contents because we have to work on real-life conditions like our players will be using. So we need to have 2 computers at least, and to have real screens, because we need to have the performance of the screens and the CPU and the GPU unaltered. Then we also needed to have an orchestrator tool that was OS agnostic, so it will be able to perform automated actions on the Windows machines and also on our different tools that we have. So what does the testing stack looks like? So at the studio in Bordeaux, we have our 2 computers that is reserved for our testing purposes. And then we have an Apostle Netropy N61. I think it might be a little bit exotic, but it's a physical device that allows us to emulate any type of network. So it's really personalizable. It has an API, so we can automate things on it. And the network between our 2 computers goes through this device. So every time we do a stream, we can we force the network to go through the netropy device. Then the core of the automation is Ansible. So we have Ansible playbooks that are the test pipelines. For those who are not familiar with Ansible, it's usually a tool that is used for server deployment and management of servers, but we tweaked a little bit how we used it to fit our needs. And then we have AWX, which is basically a web application that delivers UI and an API to manage the Ansible playbooks. And then we have GitLab, because this is where the team works, so all the work is hosted there. And during our test, we gather data from both the host and the guest, and also from netropy, and we push them inside an open source database, and we can see the results in Kibana. So I have a flow of how it works. So first, a user can manually trigger the pipeline on GitLab. It will launch a template on AWX, so the template is actually just the Ansible playbooks that is behind. And then the playbooks will perform multiple actions. So first, it will create a simple netropy path. So a path is actually the definition of the network conditions that is applied between the two devices. So first, we want a good network, because we don't want to have any impacts on the rest of the pipeline. Then we will unlock the host, and we start gather data from the streaming application that we will launch. Then we do the same on the guest. We will unlock the session of the guest computer, and then we will connect to the host stream and start to gather data. And then at this point, we will update the path with the test scenario, so with the network scenarios that we want to test, and we also gather data from netropy. And so this will be a 2-minute experiment, and after that, after those 2 minutes, we will stop the streaming on both computers. We will gather all the data and push them into the database. So this is only for one network scenario, but in a test pipeline, we have a lot of them. So every time we will redo these actions. So we will relaunch the stream, connect the stream on the guest, change the path with a new network scenario, and then we will do it for 2 minutes, gather the data, and push them into the database. So when all the experiments are done, the screen is locked on both sides. We clean everything on netropy. And then on GitLab, it's actually like in the pipeline, we still poll the results of the job on AWX. And when the job is done, well, the GitLab pipeline also succeeds if it succeeds. And then if it fails, the GitLab pipeline will fail. And then you can almost instantly see the data in Kibana. So I have also a little video, because I think it's always good to see what's happening. So we clicked on GitLab, and then we have on AWX the job that is launched. This is the netropy UI, where the path is created between the two devices. So right now it's 1 gigabyte of bandwidth, and then it changes to 300 on each side. You've seen the host and the guest being unlocked, launch the streaming, and then for the 2 minutes, we just let it happen. And once it's done, we will kill the process, log the sessions, clean everything. So it's clean on netropy. And then you will see the results. So it's done on AWX, and you will see the result that is pulling on GitLab. And last but not least, our dashboards. So it looks like that. We have a lot of data, obviously. So why did we make these choices? First, I wanted to use what was already available. So we already had the netropy device. It came before me. in the team. And actually, we had also other studios in France that had an entropy device, but we were the first team to actually use it. There is no really out-of-the-box solution, so we needed to create our own. So we had GitLab. The team uses GitLab for everything. Then we had already the OpenSearch database and the Kibana that were connected together. That was already used for streaming metrics. And then in my previous job, I was doing some infrastructure automation to create and manage infrastructure. So I already knew how to use AWX and Ansible. So first, the solution was to go with Go scripting, but I thought that it was not the best tool for orchestration. So that's why I proposed to start to try Ansible. And so far it works. It does fit our needs. We also talk with lots of teams in Ubisoft, because there are obviously tools to automate stuff in Ubisoft. But they are not good for us, because we needed to be able to exchange information between our different computers. And it was not possible with the solutions they already had, so it confirms what we've done. So to conclude, where we are now. So I talked about two goals for the test. First, understanding the tech, and then validating the change. So have you seen that the dashboard are pretty busy? It's a bit messy, we have a lot of data. So it was not the best solution to validate our changes. So because we will need to compare dashboards every time we do a change, and it's not possible. So we had to dig a little bit deeper, so I worked with one of my teammates, Rémi, did a good job. And we had to really, so when I say dig deeper, it's like really protocol level to know what's happening when we have more latency, less bandwidth, everything. And we have created a set of metrics that allow us to really validate our changes more easily. So everything is still used, it's just a bit better now because we have the metrics. And what's next? We have many projects. We also have remote play that you can test in the stand. So this time it uses mobile devices, so we need to change how the pipeline works to use phones or mobile devices. Then, right now I showed you a lot of automation with the test application, but we have real projects that are already in prod. And everything is tested with our QC teams, and now we want to automate and create end-to-end tests to help the QC team. And then we've talked about how the network impacts the playability, but we also have the video settings that can impact the playability. So we need also to start to look into that. And last but not least, there are subjective metrics, and I think it's a very good subject of research and how we can define what is a good stream. That's it. Let's make it stream. And you can come check us at our stand. You have my colleagues that developed some of the projects, or all of the projects, I would say, and it's pretty cool. So come say hi.